Hey y'all, let's cover lesson 11, solving equations involving integers. So I was wrong at the end of the last lecture whenever I said that we're only covering through lesson 11 before the next exam. We're actually covering, I think, through lesson 15. So please disregard what I said. Hopefully I didn't freak too many of you out. And let's continue with the lesson. So in lesson 6, which was the last lesson we did before exam 1, we began to explore equations and finding their solutions. So we were solving for x most of the time. And in those quote unquote equations have equal signs. All right. So those are the ones where you actually solve for an answer, an equality. So recall that an equation is a statement of equality between two expressions. So an equation contains an equal sign, and also recall that there's a variable is a symbol that stands for a value that can vary. So it can be different things. And a lot of times you'll see X is the one that's primarily used, but honestly, it could be any variable, any letter, or any symbol. All right, if a variable is if a variable in an equation is replaced by a number and a true statement results, then the number is called a solution of the equation. The solution of the equation. Is -6 a solution of the equation 2x plus 5 is equal to -7? Well, the only way we can check to see if -6 is a solution is to substitute -6 in for the variable x, or I like to use plug and chug. So we're going to take -6 and we're going to plug it in where the x is. So instead of 2x plus 5 is equal to -7, we're going to have 2 times -6 plus 5 is equal to -7. Okay, so all we have to do now is work the left side of the equal sign and make sure that it equals the right side of the equal sign. If it does, -6 is a solution. So 2 times 6 is 12. The signs are different, so it's negative. I'm going to bring down the positive 5. The signs are different, so we have to subtract and take the sign of the larger number. So checks out that yes, -6 is a solution. Remember, this is asking you a question. So therefore, whenever you're doing your exams for me, you're going to need to provide a sentence for your answer. Okay. I'm not checking punctuation or spelling or capitalization or anything. I just need to make sure that you understand what we're doing. Okay. So recall that two equations having the same set of solutions are equivalent, hence the equal sign. We can provide equivalent equations by adding the same quantity to both sides of the equation. So if we have A equals B, we can have A plus C, a constant C, that we would have to add to both sides. All right. Same thing, if we have A equal B, we can have another C, another constant, that we can subtract from either side. And it still stays equal. I'm sorry, minus C. I said the word equal, so it came out. So if we have, say, two terms equal, all right, that means if I take those two terms and I add the same number to both sides, it still is going to be an equal values. The same thing as if we subtract the same number from both sides, it still maintains equality. All right. Multiplying by the same quantity. Again, if we have an A equal B, we can multiply a C times both sides, and it still maintains the equality. And division as well. If we have A equal B, we can divide both sides by the same value and still maintain equality. The only exception for both of the multiplication and division is 0. Okay, that's the only thing that's going to change. All right, so these techniques do not change when we expand our scope to include the integers. So let's solve for the x. So this has x plus 3 is equal to -7. So that means that the left side is equal to the right side given a specific number. All right. Now, the thing I ask myself is, whenever I see this, X plus 3 is equal to -7. Who is attached to X and how? Because we want to know what we have to do to the who to get them away from the X. All right, because we want X isolated all by its little lonesome on one side. So I just said up here, well, first of all, it's 3, and 3 is attached to X by addition. So we have to do the opposite of addition, which is subtraction. And we learned up here that if we subtract the same number from both sides, we're still maintaining that equality. So that works. So I can subtract 3 from here and get X by itself because this becomes 0. But I still have to do the subtracting 3 from the other side of the equal sign in order to maintain that equality. Okay, so my signs are the same, so I'm going to add them and keep the sign. The answer for this is X is equal to -10. Okay, solve for X. So we have X minus 8 is equal to -11. Coming back up here, who is attached to X and how? 8 is attached to X by subtraction. All right, so what's the opposite of subtraction? Addition. And I learned up here that I can add the same number to both sides and maintain that equality. So I can add 8 because that's what I have to do to make sure it goes away. And I'm only left with an X on one side. But what I do to one side, because of this little guy, I have to do to the other side. The signs are different. So we have to subtract 8, 9, 10, 11. So that's 3. And this, we have to take the sign of the larger number. So X is equal to -3. There's a really cool thing we can do here as well. We can check these answers to make sure that they're right. So I'm going to take that X plus 3 is equal to -7. And I'm going to take the -10 that I got and substitute that in for X and make sure that both sides of this equal sign work out correctly and that I didn't mess up something whenever I did my calculations. So my signs are opposite. I subtract and take the sign of the larger number. That works out great. Coming down here, I've got X minus 8 is equal to -11. Again, I'm going to substitute that -3 in for X and make sure that both sides of my equal sign work out. The signs are the same, so we add the two numbers, 8, 9, 10, 11, and we take the sign that they have in common. That checks out, so -3 is the solution for X in this one. Please make sure that you're writing down any questions you have for me so that I can go over them with you either in a tutoring session, an office hour of mine, or during class or after class. I'm available before class for half an hour. So 8 o'clock, no one's in there, y'all. Please feel free to pop in and see me. All right, so we're going to solve for Y. I need a drink. I've got -8 plus 2 is equal to Y minus 11 times -4. It's cold, but it's beverage. Okay, let's play. All right, oh gosh. All right, we got a lot to do here. It looks like we have a lot to do here. We really don't. So check this out. It looks kind of obnoxious, but it's not. -8 plus 2 is on one side. So we're just gonna combine those. And then on the other side, we have Y minus 11 times -4. All right. Keeping in mind order of operations, I'm going to just deal with my left side since they're not on the same side. I can treat them differently. So they're different signs. So I need to subtract and take the sign of the larger number, bring down my Y, which I'm solving for. I'm going to combine these two because it's multiplication. 11 times 4 is 44. The signs are the same. So negative times the negative is a positive. All right, now it looks much easier. Now I can ask my question, who is attached to Y and how? 44 is attached to y by addition. The opposite of addition is subtraction, or the inverse of addition is subtraction. So we have to subtract 44 from that right-hand side of that equal sign so that y can be isolated all by itself. So I'm going to subtract 44 from over here. And so this goes away and I'm left with y. But me doing that causes an imbalance in the equality until I subtract it from the other side. Have to keep everything equal. And then the signs are the same, so we add them and keep the sign. So y equals 50, negative 50. Okay, not too bad. Solve for x. All right, well, we've got negative 3x is equal to 30. The question is, who's attached to x and how? Negative 3 is attached by multiplication. Okay, because it's multiplication, the opposite or inverse of multiplication is division. So we have to, well, you need to understand that any number divided by itself is 1. And that's our goal here, is to get this to be a 1 to the left of x so that x is by itself. So to do that, we have to divide that negative 3 by itself. What you do to one side versus this guy, we have to do to the other. All right, so negative 3 divided by 3 is 1. Anything divided by itself is 1. X is equal to 30 divided by 3 is 10. And then we have a positive divided by a negative. So the signs are different, so therefore it has to be a negative. All right, we didn't check that last one. I want to go back and check. We can check it, yeah. So let's check both of these. So I'm going to go ahead and do the negative 8 plus 2 we did was negative 6. All right, so that side's done. Now I want to see if my right side's the same. So we've got y plus 44. That's what I want to deal with. And I'm going to plug in, what number did we get? Negative 50. Negative 50 plus 44. Why did I choose this part of the equation to write down instead of the original? Do y'all know? It's because we've already tightened it up and cleaned it up to where the left side is just one term and the right side is just our variable and one term. So instead of having to rework this, we can save time by using what we've tightened up before we started moving things around. Okay. So now we have negative 6 is equal to, the signs are different, so we subtract and keep the sign of the largest. That works out great. Coming down to this one, negative 3 times, we got negative 10 is equal to 30. 3 times 10 is 30. And the signs are the same, which makes it a positive. A positive times a positive is a positive, and a negative times a negative is a positive. When two signs of the same are multiplied, they are positive. All right, so that worked out great. Solve for x. We have x divided by negative 2 is equal to negative 20. So this can be looked at multiple different ways. The one thing I want to show you is I'm going to ask the same question I always do. Who's attached to x and how? That I swear that never fails me. Who's attached to x and how? Because then all you have to say is, okay, negative 2 is attached to x by division. All right, I'm going to write that. Negative 2 is attached. This is my conversation I have with myself. Attached to x by division. So I've answered my question. No, you don't have to write this down, but these are the questions you should be asking yourself. And then what is the inverse or the opposite of division? And that's multiplication. So that's the next thing I do. So I'm going to take the x divided by negative 2. I'm just rewriting it. And I'm going to multiply the opposite of division to both sides. Okay. When you're multiplying a fraction, remember this negative 2 is over 1 because it's a whole number. All right. When you multiply fractions, I know we haven't done this yet. I know we haven't dealt with fractions. That's our next one. You multiply straight across. So negative 2 times x is negative 2x. And then 1 times negative 2 is negative 2. The reason I'm multiplying this is to show you, and I'm only doing the left side right now, that -2 divided by -2, anything divided by itself is 1. So now we have 1x, which is exactly what we want on that side. We want an x all by itself, okay? So that's my left side. Now I can come over here and deal with my right side of the equal sign. 20 times 2 is 40. I'm so sorry. And a negative times a negative, or any signs, when both numbers have the same sign and they're multiplied, it's positive. So equals, equals. And that's it. So x is equal to 40. We can check that. X divided by, let me give myself some space here. X divided by -2 is equal to -20. I'm saying it's 40 divided by -2 is -20. 40 divided by 2 is 20. And a positive and a negative, the signs are different, so it has to be a negative. So that worked out great. All right. What's the next piece? Oh, this is okay. So recall, I'm going to do this. It's not my favorite one, but I'm going to do it. Recall the wrapping and unwrapping processes we discussed in lesson 6 when we were solving for those variables. They were talking about wrapping the present, and then we have to put the wrapping paper on, then we got to take each of the layers off. So instead of saying the wrapping stuff, for me, this is what I'm saying. This is exactly what I'm saying. Who's attached to X and how? Okay. That's what you need to know so that you know who to get rid of and how, by doing the opposite or the inverse of them. Okay. But please feel free to pause and read this or look at it on your notes. If it makes sense to you, keep going with that. I'm going to keep going with the words that I like to say because I feel that they've helped the students the most, because then you don't have to sit there and think about which part of the step is the tape and which part of the step is the wrapping paper. And I'm just, no. Suppose we have a machine that takes the input, oh, this is good, then multiplies the input by 2, and then adds 3 to the result. Okay, this I like. So this is something that I noticed that y'all struggle with. It's taking the words and putting it in the math language, because the math language is just words. You've never heard me say a math word that's not from the English language. So it's just learning the terms that match the English language. So suppose we have a machine that takes the input. So we have a machine. Let's see if I can do this. We have a machine and it takes the input. This is our input. I'm not good at drawing. Multiplies the input by 2. Multiplies it by 2. And then adds 3 to the result. Okay. What would be the steps in a machine that would undo this process? Okay. So the opposite, so this is like saying that this input's my X. So let's do that. That means we have X times 2 plus 3. Okay. If I say who's attached to X and how, I start with the part that's furthest away from the X, but that's still attached to the X. Okay. It's like looking at PEMDAS. Let's check this out because it's literally the opposite. It's PEMDAS in reverse. MD. I wonder if I can make a thing out of it. EP. All right. So addition and subtractions first. Here's addition. So we need to get rid of this one first. The opposite or inverse of +3 is subtracting 3. So we would have to subtract 3. All right. Then after we subtracted 3, we would have X times 2. Okay, who's attached to X and how? 2 is attached by multiplication. The opposite of multiplication is division. So then we would have to divide by 2, because 2 divided by 2 is going to give us a 1, which will give us the X that we're looking for. So the first thing we would have to do is subtract 3. And the second thing we would have to do is divide. Divide by 2. So it says what would be the steps in the machine that would undo this process. These are the 2 steps in those orders. Okay. All right. So here's the process. All right. They did better processes than me. All right, so inputting an X, they multiply by 2, and they add 3. To solve for it, you have to subtract 3 and divide by 2. For example, drop the integer 7 into the left machine above. So if we put 7 in here, what is the result? So we would take 7 and multiply it by 2 and add 3. All right. Well, we have to multiply first, and then we would have to add. So 7 times 2 is, I know I'm supposed to do this vertically, but I don't have room. 7 times 2 is 14 plus 3. 14 plus 3 is 17. Okay. What happens when we take the result and run in through the undoing machine on the right? So this is our undoing machine. Does that miss me? This is our doing machine. I like that. That's fun. Doing and undoing. All right. So that means we would take our 17 and we would subtract 3 and divide by 2. So we would have to divide all of it by 2. Be careful. I know you're using your calculators, okay? So I want you to do both of these steps in your calculator, please, because I need you to understand how important it is to use parentheses on your calculator, because your calculator is only going to do what you tell it to do. So if you took this and you did 17, and this is not right, but I want you to do this in your calculator, 17, subtract 3, and then divide by 2. I want you to put that in your calculators. You're going to get a fraction, okay? You're going to get a decimal. Because what your calculator is doing is 17 to minus, and then it's doing the 3 divided by 2 first. Well, 3 divided by 2, you're going to get a 1.5. 17 minus 1.5, so you should have gotten what? 15.5, okay, for your answer. And that's what you plugged in, and that's not what you're supposed to be doing. Now, in your calculator, do this. Put parentheses. Parenthesis, 17 minus 3, close parenthesis, divided by 2 equals. Now you're going to get 17 minus 3 is 14, and then 14 divided by 2 is 7. Muy importante. Y'all have got to make sure that you're using parentheses or do the steps individually, because you could have gone 17 and then subtract 3 equals, and then divide by 2 equals. Okay. I have found that you want to put it all in at once. And so when you do that, you need to understand your order of operations and make sure you're putting parentheses, right? Consider the equation 2x plus 3 is equal to 7. The left side of the equation gives us the machine, and the right side of the equation gives us the information to determine what the original input was based on an output. What are the steps of the machine in this equation? All right, well, we've got 2x plus 3 is equal to 7. So the steps for the machine's on our left here. This is multiplying by 2, whatever number we plug in for it, because this would be 2 times, let's say, 4 plus 3. I'm only looking at the left side. So the first thing I would do with that 4 is I'd multiply it by 2. And then I'm going to add 3. And then add 3. How can we undo these steps? Well, the opposite of addition is subtraction. So we're going to subtract 3. And the opposite of multiplication is division. So then we would divide by 2. Okay. The undoing process is how we will solve the equation. That's how we're going to solve for x. So let's solve for x on this. 2x, I'm just going to rewrite it, plus 3 is equal to 7. To undo, I need to subtract 3. What I do to one side, I'm doing to the other, keeping it equal. I'm left with 2x, this becomes 0, is equal to, the signs are opposite, so we subtract and take the sign of the larger number, which is positive. Who's attached to x and how, which is what I've been doing since up here. I know we're talking about the undoing, but it's also who's attached to x and how. Currently, it's 2 is attached to x by multiplication, and we have to divide by 2. So whichever one you like, the undoing steps, which are great, or if you like the who's attached to x and how, use whatever works for you. I don't need to know, just make sure it does. So 2 divided by 2 is 1, so x is all by itself now. 4 divided by 2 is 2. The signs are both positive, so our answer is positive 2. To check, that's just 2 times 2 plus 3, plugging that in for the formula, the equation. 2 times 2 is 4, plus 3. The signs are both positive, so, and then 4 plus 3 is 7, equal to 7, and we are golden. All right, solve for x. I'm just going to rewrite this. Okay. So this is going to be something new for you, all right? And I need you to pause whatever you're doing, do not be distracted, and pay attention, because this is something my other classes, in fact, I don't know of very many people who do not struggle with this problem. And it's because they don't understand it initially, and I want to help you do that. When you have a problem that has a fraction, I know you do not like fractions, okay? So breathe first, all right? I need to see, and I need to stop, and I need to ask myself the questions I ask. Who's attached to x and how? So if I were to plug a number, ignoring this -7 over here, if I were to plug a number in for x, what is the first thing I would do? I'm going to come back up here and think about what would I do for this problem? And to do this problem, say I plugged in a 4 for this. Well, the first thing I would do is divide by 4. Okay, so if I'm going to do it, I'll just do a little side note over here for me. If I'm going to do the problem, I'm dividing by 4. And then what am I doing? I'm subtracting 3. I like this. I like thinking of the do and undo. To undo this, therefore, I need to do the opposite of subtract by 3. I need to add 3. And then I need to do the opposite of division, and I need to multiply by 4. So this is what I need to make happen in order to solve for x. Okay. The other way that I ask myself is, again, who's attached to x and how? 4 is too close to x, so I need to go with 3 because it's farther. 3 has got a subtraction sign, so I need to do the opposite, which is add 3 to both sides. Add 3, which when you're doing this process, the do's and the undo's, you're doing it to both sides to keep the equality. So now we have the equal sign comes down. X divided by 4. 7 and 3, they're both different signs, so I'm going to subtract them and take the sign of the larger number. Okay. Last step, multiply by 4. The other thing I ask myself, who's attached to x and how? 4 is attached by division. Opposite of division is multiplication. I'm going to multiply this side by 4. And what I do to one side, I always do to the other. 4 divided by 4 is 1. So we're left with x is equal to 4 times 4 is 16. They're different signs. Negative times a positive is a negative. We can check this. Just plug in the -16 for x. Just substitute it. All right. 16 divided by 4 is 4. They're opposite signs. Negative divided by a positive is a negative. -3 is equal to -7. 4 and 3, they have the same sign, so we add them and keep the sign. Works out great. We're golden. All right. Last page. Oh, nope, there's more pages. Okay, this is a long lecture. My goodness. All right. Solve for t. Oh, they're throwing in a different variable. Cool. Get comfortable with that, because you're going to see all sorts of them, because you're at least going through my problem solving class. 0 is equal to 8 minus 2t. The goal here is to isolate t all by its little lonesome on one side, all by itself. So I need to see what steps, and if we want to do the undo and do process, I like that. I'm going to keep asking who's attached to X and how, or T and how. 8's furthest, so, and it's positive, so I have to subtract 8 from both sides first. And I'm left with 0 minus 8 is negative 8. These are gone, 0, and then negative 2t. Okay. Who's attached to t and how? Negative 2 is attached by multiplication. Opposite of multiplication is division. What you do to one side, you do to the other. Negative 2 divided by negative 2, anything divided by itself is 1. We're left with t on the right. 8 divided by 2 is 4. The signs are the same. Negative divided by negative is a positive. To check this, 0 is equal to 8 minus 2 times, and let's substitute that 4 in. 0 is equal to 8. 2 times 4 is 8, and bring down that negative and a positive is a negative. So the signs are different. And 0 equals 8 minus 8 is 0. So works out great. Solve for P. We need to clean this up first. There's too much going on that's not even attached, that's not even necessarily attached to the P. So let's condense this. The other words are simplify or combine like terms. Pick your poison. It all means the same thing. I'm going to start with my left side over here. I'm going to rewrite this. Negative 12 plus 3 is equal to negative 8 plus 4 plus P divided by negative 3. All right, so my left side of the equation is all I'm touching right now. The signs are different, so we're going to subtract them and take the sign of the larger number. That's nicer. I can combine these two as well. So 8 is negative, 4 is positive. I need to subtract them and take the sign of the larger number. I'm going to bring down that positive P divided by negative 3. Pardon me. Sorry, y'all. Sorry about that, y'all. It scared the heck out of me too. All right, so now we're going to start getting rid of thinking about who's attached to P and how, or the undoing process. So to undo, or who's attached to P and how, we've got this negative 4 is attached here. The opposite of the negative would be, or subtraction would be, a positive 4. So we're going to add 4 to both sides. 9 and 4 have different signs, so we have to subtract them and take the sign of the larger number. These give us 0. 4 minus 4 is 0, and then 0, 0. And then we just bring down our P divided by negative 3. Okay. Undoing, or who's attached to P and how. Negative 3 is attached by division. The opposite of division is multiplication. So we're going to multiply both sides by the negative 3. All right, the left side, 3 times 3 is 15. The signs are the same, so it's positive, or negative times a negative is a positive. This becomes, I'm going to show you over here to the side, P, negative 3P over negative 3. Negative 3 divided by negative 3 is 1P. So this is just P. These reduce. P is equal to 15. To check this, I'm going to do like I did the last one and use the one that's already tidied up a little bit. Negative 9 is equal to negative 4 plus 15 divided by negative 3. All right, I'm going to bring down my negative 9 and negative 4. 15 divided by 3 is 5. The signs are opposite, so it's negative. The signs are the same, so we add them and keep the sign. Worked out great? Fabulous. Recall our procedure for solving application problems is 1, we need to set up a variable dictionary. Set up a variable dictionary. 2, we need to write an equation using those variables, using the variable. All right. 3, we need to solve the equation. 4, we need to answer the question, complete sentence. Answer the question. And that means complete sentence. Complete sentence. Correct units and correct rounding when needed. That is what's required when there's words in the problem. And then the last thing is to look back and check. Look back and check. Does your answer make sense? And I've mentioned this before to where I've had people in the next class that you're going to be taking give me some crazy answers, like somebody paid $15 gazillion for a house or something. I don't know. It's just it was crazy. Just couldn't. All right, so let's do a couple word problems. A student's bank account is overdrawn. After making a deposit of $120, he finds that his account is still overdrawn by an amount of $75. What was his balance before he made his deposit? Okay, so I'm just going to write down some things. So this is a lot happening here. Deposit of $120. A balance before the deposit. I'm going to label that as X because we don't know what it is. All right, that's our unknown. And then balance after deposit. Deposit is overdrawn by an amount of 75. Well, if I write just 75 for balance after deposit, then that would mean he has $75 in his account. But if he's overdrawn by $75, that means he still owes the bank $75. He's still short $75. So that has to be a negative. It's still overdrawn. Okay. So we need to create an equation of what's happening here. We need to know, okay, we've only got 3 things here. We've got a deposit, a balance before deposit, and a balance after deposit. So what we could say is we're going to add together the deposit and the balance before deposit, and that's going to give us our balance after the deposit. So I'm going to write that out so hopefully it makes sense. Balance before the deposit. And then we're going to add plus the deposit is going to equal the balance after the deposit. Okay, so the balance before the deposit is X. And we're going to add the deposit, 120, is equal to balance after deposit is negative 75. Just substituting what we figured out. All right, so now who's attached to X and how? We need to know what is the balance before deposit. That's the question. 120 is attached by addition. The opposite of addition is subtraction. So we're going to subtract 120 from this side. What we do to one side, we have to do to the other. And we get X is gone is equal to, the signs are the same, so we add them and keep the sign. So we did all that. We solved it. What was the other thing we were supposed to do? Answer the question. We solved the equation. Now we're going to answer the question. So the question is, what was his balance before he made his deposit? I'm going to use their words because I don't want to have to think too hard. His balance before he made his deposit was, his balance before the deposit was, and then negative $195. you could write also negative 195. I like negative $195. Please don't put the dollar sign behind it. That's not what we do in America. I'm not sure where that even started. It's inaccurate. All right. 3 more than twice a certain number is negative 11. Okay. Find the unknown number. Well, we need a dictionary, so we're going to let X equal our unknown number. I could choose any variable or sign, but we'll just go with X. And 3 more than. So that means if you have something, that means you've got 3 more than that. So that's something plus 3. 3 more than twice a certain number. So 3 more than twice. If I were to call somebody twice, that would be 2 times. So that's 2 times that certain number, 2x. So 3 more than something twice a certain number, so that's 2 times a certain number x, is always equal, is negative 11. Okay. 3 more than, so that's going to be something plus 3. Twice is 2. 2 times a certain number. Well, we said that's going to be our unknown number is x. Is always equal, and then negative 11. So now we can find the unknown number. Who's attached to x and how? 3 is by addition, so we need to do the opposite of that to both sides. 2x is equal to, this is gone. The signs are the same, so we add them and keep the sign. Who's attached to x and how? 2 by multiplication. The opposite of multiplication is division. What we do to one side, we do to the other. 2 divided by 2 is 1. So now it's just x is equal to 14 divided by 2 is 7. A negative and a positive, the signs are different, so it's a negative. To check ourselves, all we have to do is go to, I'm going to take the 2x plus 3 is equal to negative 11. I'm going to substitute that negative 7 for x. And just check my work. I have to multiply first. 2 times 7 is 14. The signs are different, so it's negative. Bring down everything else. Negative and a positive, we have to subtract them and take the sign of the larger number. It checks out, so negative 7 is our unknown number. We need to answer the question. The unknown number is negative 7. That's it. Oh, that's the end of the lecture. Fabulous. All right, let me know what questions you have. I'll see you in lesson 12.